Welcome to SimplyGIS, GIS for everyone.
Welcome to SimplyGIS YouTube channel. In this video, I will demonstrate how to calculate land surface temperature from Landsat satellite images. We all know band 10 and band 11 of Landsat 8 and 9 satellite images are the thermal bands. Basically, band 10 is used to create land surface temperature. The process of calculating land surface temperature include first creating top-up atmospheric radiance data by converting the digital number values to TOA values. Then the TOA raster is used to create brightness temperature raster. At the same time, band 4 and band 5 are used to create NDVI, and that NDVI is used to calculate proportionate of vegetation. Using the proportionate of vegetation, we can calculate the emissivity. Finally, the brightness temperature and emissivity are used to create land surface temperature. This method of calculating land surface temperature from Landsat is also known as traditional method, where you generally use Landsat collection to level 1 data. This is very important to consider before calculating LST. You might have noticed Landsat offers different levels of data while downloading from USGS Earth Explorer. As you can see here, there are Landsat collection 2, level 2, collection 2, level 1 data. The collection 2, level 1 data provides bands in raw formats where the values are digital numbers. Whereas Landsat collection 2 level 2 products comes in two different groups. One is level 2 surface reflectance bands and second is level 2 surface temperature bands. And band 10, which is temperature band, can be found in this group, and band 4 and band 5 can be found in this group. What is interesting, level 2 data are advanced and they are both atmospherically and radiometrically corrected, and they provide the ready-made information about the surface temperature. I have already made a video how to calculate LST in easy and simple way using the level 2 data. For calculating land surface temperature using this method, traditional method, you need to use level 1 data. For level 2 data, I have a separate video. You can check that. I will demonstrate this in QGIS, which is an open source software. I have imported band 10, band 5 and band 4 of my study area. First, I will create top of atmospheric radiance using band 10. The formula for converging digital number to top of atmospheric radiance is L lambda is equal to ml multiplied by qcal plus al. Here ml is equal to radiance multiplicative value of band 10 and al is equal to radiance additive value of band 10. And qcal is the digital number, quantized calibrated digital number, that is the band 10. You can get this ml and al value from the metadata file provided with the data. I will suggest you to download the metadata file while you are downloading all these bands from the USGS portal. In this metadata file, you can find the ml value and al value. Radiance, here is the value. Radiance multiband value 10 and al radiance additive value band 10. These two values will be used. As you can see, this radiance multiband 10 value is exponential value. We need to get exact value from this. So I will copy this and open Excel. You can check this value in Google also. So when I am writing this value here, Control B, Control paste. So you can see this is the exact value 0.00038. So this is the ml value of my band 10. To calculate QA, we will go to raster calculator. So here is the raster calculator, and in raster calculator we will write this formula ml. So I have copied the ml value 0.0038, control C. Okay, so control V, ml value multiplied by ml multiplied by qcal, that is the band 10. So I'm double clicking on the band 10. So ml multiplied by band 10, then plus al. So let's go find the al value. Radiance additive band 10, this is the al value, control C. So I'm going to raster calculator, plus control V and bracket close. So you can see the expression is valid. Now we have to save this POA to a destination folder, output folder. Okay, I'm browsing it and I'm saving it as POA. Okay, .tif. Save. It will be saved as geotiff. Now click OK. So you can see this is the top of atmospheric radiance. Using this top of atmospheric value, I will calculate brightness temperature. So this is the formula of brightness temperature, where you can see K1 is equal to constant for band 10. L lambda is the top of atmosphere which we have created just now. So this K2 and K1 value can be found again in the metadata file. You can see this is the K1, K2 constant band for both band 10. So I'm going again to the raster calculator, then K2 value. My K2 of band 10 is, this is the K2 value. I'm copying it. So within bracket K2 divided by ln, then K1, right? So this is the K1 value. I'm copying it. K2 divided by ln K1 divided by top of atmospheric plus 1 minus 273.15, because we want to calculate the brightness temperature is degree centigrade. That's why I'm putting minus 273.15. Again, I'm saving this to the my destination folder, vt tif, save. Okay, okay, okay. Okay. So this is the brightness temperature of my study area. So I have calculated both the TOA and BT. The third step is creating NDVI. So again, I will go to raster calculator. You all know that NDVI is calculated using NIR and red band. In Landsat 8, band 5 is the near infrared NIR band and band 4 is the red band. So I will put the formula band 5 minus band 4 divided by band 5 plus band 4, bracket close. Expression is valid. I am saving it as ndvi.tif, save. Okay, so my ndvi is done. Using this NDVI, I will create the proportionate of vegetation. So you can see this is the formula proportionate of vegetation. NDVI minus NDVI minimum divided by NDVI minus NDVI max minus NDVI mean and square. For that reason, we will go to raster calculator. Then formula is NDVI minus NDVI minimum. So you can see what is the value of NDVI minimum? 0.135261. 0.135269 bracket close divided by NDVI max 0.460872. This is the NDVI max value minus this is the NDVI minimum value. So again I'm copy pasting it, bracket close, and you can see there is a power of the square of the formula. So I will put this by this is the power, clicking it and writing 2. 2. So you can see this is the power, square power. I'm saving it as pev.tif, save. Okay. So this is the proportionate of vegetation. Now from this proportionate of vegetation, we will calculate emissivity. So the formula for emissivity is this. So let's go. Again, I'm going to raster calculator. 0.004 multiplied by PV plus 0.986. You can see this 0.986 corresponding of correction value of the equation, and 0.004 is a constant here. Okay, saving it as me.tif, save. Okay, so you can see this is the emissivity value of my study area. Now it is the final term to calculate the land surface temperature. For that we need bit brightness temperature as well as emissivity raster. The wavelength of the emitted radiance, this is, so the values of wavelength for Landsat 8 band 10 is 10.8. This is the average value of band 10, and C2 is calculated by using Planck's constant, Boltzmann constant, and velocity of light. As you can see, C2 is equal to H multiplied by C by S, and the C2 value is 14388. Okay, so I will calculate this. Let's go to raster calculator. So LST is equal to brightness temperature divided by, as I showed you, 1 plus wavelength value, that is 10.8 multiplied by BT divided by C2 value. As you can see here, C2 value is 14388. So I'm writing it 14388, bracket close, multiplied by ln, then emissivity, bracket close, bracket close. So this is the formula. Let's check it. BT1 BT divided by C2. Okay, I'm saving it. LST.tif, Save. Let's run it. So you can see this is the final output where minimum temperature is 21 and maximum temperature is 35 degrees centigrade. Let's make it more visually appealing. Right click on the LST layer, properties, symbology, single band pseudo color. So this is the LST of my study area where the dark red parts are the higher LST areas and the blue areas indicate low LST. In this way, you can create land surface temperature from Landsat 8 and 9 data. SimplyGIS is offering 6 months course on basic of remote sensing and GIS. You can visit our website simplygis.in and check details about the course. It is a 6-month course. The classes will be held online on Saturday and Sunday. The time is flexible. Here is the registration form. You can click and register yourself. This is the detailed course structure. For more videos on remote sensing and GIS and tutorials of QGIS and ArcMap, please subscribe our channel SimplyGIS and also click on the notification icon. There are playlists on QGIS and ArcMap. You can check them.